All right, so here we are on this spooky, scary Tuesday right before Halloween. And I thought because it was Halloween, I would play some spooky, scary skeletons for you. Here you can see my spooky, scary skeleton tie. And in the spirit of Halloween, I thought we would do something that was a little scary for two reasons. One, it has a little bit of algebra. And two, we're thinking about the depth of a deep, dark, creepy well. So today what we're going to use is this equation, distance equals 1/2 gt squared, to figure out the depth of a deep well that we drop a pebble or a rock down. So let's take a look first at the equation we're going to use so we can figure out some of the tools we have to solve this question. So here is the falling object equation. And this really just gives us a very quick, easy way to solve for the distance if we know the time that something falls here on Earth. Now, one important thing to keep in mind is that this only really works on Earth, where gravity is 9.8 meters per second. We could change this gravitational constant for another planet or another location, but 9.8 meters per second is what we use here on Earth. And the other thing that's important to keep in mind is that this assumes no resistance from wind. So it doesn't really work with perfect accuracy in the real world, but in a vacuum, it does. This is exactly how it works in a perfect vacuum. So let's take a look at this. D gives us our distance in meters. We have the quantity 1/2. We have G, which is our acceleration due to gravity, and then our time squared. So that's always in seconds. So distance is equal to 1/2 gt squared. And we can use that again to solve for depths or heights of a dropped object. So let's take a look at exactly how we might go about doing that. Using a question. Now remember, we could do this without this. We saw how to do that in class. We could figure out the depth of the well with a 5-second drop time. But it's hard. We have to find average velocities per every interval of time, for every second, and that's kind of annoying. So we're going to do it a slightly quicker way using distance equals 1/2 gt squared. So let's read the problem first. How deep is the well if a rock falls for 5 seconds before splashing? So you drop a rock, splash down at the bottom, you count it to 5. How deep is it? Well, we have almost all the information we need. So let's start with this. What we do not know is the distance, so that's what's left blank. We have 1/2 gt squared, and we can go ahead and fill in some of these things. We know that's happening on Earth, or at least we can assume that. So distance is equal to 1/2 9.8 meters per second times time, which is 5 seconds squared. So, using our sort of PEMDAS rules here, we can just go ahead and first off, get rid of this exponent. 5 squared is 25, again, times 9.8 meters per second squared times 1/2. So now we just multiply across. 1/2 times 9.8 is 4.9 times 25. Now, those of you guys who've had my class for a while know I'm not the sharpest on my long division or multiplication, so just to be safe, I'm going to use my handy dandy calculator here to calculate the time. So 4.9 times 25 is going to give us 122.5 meters, and that seems about right. 122.5 meters. And that is not, I said before, our time, but that's actually our distance. That's the distance. That's how deep that well is. That's a pretty deep well, to be honest with you. 122 meters, that's a lot of feet. That's a deep well. So hopefully you're not hanging out at the edge of any of those wells here on this spooky, scary Halloween. Au revoir.